Hello, good morning everyone. Today we shall see what are template functions. So we define templates for building algorithms which work on any data type. So the way to declare a template function is to use the keyword template. Then we can use in angle bracket type name and define a generic type t. Now let's say we want to find out the larger of two numbers, which will return larger of two numbers that are passed to a function. So the return type is t and we write it as max of 2, something like this. And the two arguments are of the same type and we can name them as a and b. As you can observe, I am using data type of a and b as t. So the way this works is you just use a greater than b and then you say a colon b here and provide a return type, because the return type is again of type t. So this should work for data of different types. So if I see out max of 2 passing two integer numbers, it should give me the maximum of 2. So if I run this program, you will observe in the terminal that you get output as 7. So it will take some time to compile. As you can see, you got 7. Similarly, if I pass data of double, then also we should get the output as 7.9. So this should work fine. Similarly, if I pass a character data type, let's say D, and then A here, I should get the output as D. Right? However, this will not work for string data types. We shall see why. If I say hello and then second argument as world, result expected is world, we get it as hello. So this is not working for us for strings. Now way to get around this is what is called as template specialization. The way to do that is again use the keyword template, but this time with an empty angle brackets. The return type here would be const char star and name of the function is max of 2. And here the specialization should be specified again as const char star. The two arguments are again constant strings, const char star b, and within this I have to use string compare by passing a comma b. If the result is greater than 0, return A, else return B. If I run the program, I should get the output as world. So just observe how we could do the specialization of the same function max of 2 for string literals that we are passing to max of 2. Okay, so let's see how more of these kind can be done. For example, you want to exchange two strings or exchange two numbers. So this is not going to return anything. So first thing is we have to declare template and type name as t. Here we are assuming that both the inputs are of the same type. So exchange TA and TB. Now this exchange should happen through a reference, so I should use ampersand here. Okay. And within the body of this I should use a temporary variable temp and first save A in temp, and in A you copy B and in B you copy temp. So this should exchange two numbers. So let's see whether that is happening here. So let's say int x equal to 7 and y is equal to 9 and we can call the function exchange by passing x comma y, and you can see out the numbers after exchange as some message, and you will see that x and y, if I display them, and we shall put here also, so that you get the result on the next slide. As you expect, the output should be 9,7, right? So this is working well for your integer values. Suppose if I change them to float, 7.4 as the next number and 1.4 as the first number, so the exchange is happening perfectly fine. So does it happen for string literals? Let's see. It should work without any problem. String x equal to let us say Girish, and y is equal to Arvind. So it should work perfectly fine. Okay. So after exchange, Arvind will be displayed first and then Girish. So this doesn't require any specialization. All right. So as you could see, we need to write template functions within the template keyword, and in angle bracket you write the keyword type name and specify a particular type. Okay, and then within the body of this, if any third variable is required, you can declare again of the same type t and make use of the template specialization. All right. Now if you want to build a more serious application like sorting a set of numbers, okay, or set of real numbers or set of strings, then let's say how we can do that using bubble sort. So here again I will write a generic bubble sort using template type name t, and here bubble sort is not going to return anything, and it's going to accept a generic array, and second one is going to be a specific size. So this is going to perform the sorting. So this requires two loops: int I equal to 0, I less than size, I plus plus. So this will count the number of iterations, and within the body of this, for int j equal to 0, j less than size minus I minus 1, and j plus plus. Put a extra flower bracket here, that should go. So here what I am going to do is I am going to check if a of j is greater than a of j plus 1. In that case I am going to call exchange aj comma aj plus 1. So if required, the exchange will happen, otherwise it will proceed just as before. Alright. So now let's see whether we get sorted list. First let's try with integer array a square bracket equal to some numbers here, let's say 4 numbers, and then you can just call that bubble sort a comma 4, and we want to display this for int x colon a cout x little space. Alright, so now if you just see, the list gets very, but problem is I have already given sorted list, so let me put it in some random order and see whether the elements get sorted. So first number should come 5, 7, 14, 16. So we get the sorting that is happening. If I want to check with other data types, let's say double, and here I can put 1.4, and this can be 5.9, and this can be 1.6, and this can be 7.8, and here it should be double. So let's see whether it works fine for us. Yeah, this is working perfectly fine. Alright. Now the problem is with respect to string. So does it work from string literals? That is what we have to see. Let's say string names. So here I am going to put Girish, then Ajay, Sri Hari, and then let's say Ganesh. So these are some string literals I am passing. So we need to check whether this works fine with string literals also. So you can say bubble sort names, and then size is again 4, and if you want to list them for string yes names, cout yes, and then regular space. Okay, string names, it should be an array here. As you can see, the elements get sorted Ajay, Ganesh, Girish and Srihari. So there is no need for any specialization. So the algorithms works perfectly fine even with string literals. Alright. Yeah. So we saw how to do template functions and template specialization as required. Similarly, if I wanted a template class, how would I define a template class and do some computations? So for that again you have to use the keyword template. Let's say here I'm going to use tag name T, and then let's say we have a class bank, and within this bank we may have name as a string, whereas account number can be of string or whatever. So T account number, this can be integer or it can be alphanumeric. So I need to have a constructor for this bank, and within this I'm going to send the name and also send the account number. So I will use the initialization, inline initialization. So name of n, comma account number of an, and then log bracket here, and you can have a method void show where you want to display customer name colon name and account number as account number, possibly and that. Okay, so we have a class which uses one data member as generic data type, and we can employ this generality to create a class. So I can use bank B1 and I can pass some name J here, and first time I will pass account number as integer, and we'll try to display the account detail just by calling show method. Let's see whether it works for us. So if I run the program, it should work without any problem. So account name is Ajay and account number is 1000. Now second part can be a general data types, which can be account number, can be let us say ICICI 17. So this can be the account number. So even now it should work fine. So the account number is this. Alright. Similarly, normally account numbers will not be real numbers, but we can try something like this. It is meaningless in real world scenario, but nevertheless it works, because with account number we are not going to do any manipulations. Alright. So this also works fine. Similarly, it can be a single character also. So it can be just C1, C just like that. Okay. So classes can also be generalized. Any data member which is of generic in nature can be specified as of type T. Now this is not limited only to type T's. Let us say sometimes you want to have the balance again of generic type, so you can use U here, and here you can say U balance. Alright, so when you initialize the balance, you can say UV, and here comma balance bracket B, and you can display that balance amount also. So this balance amount can be of type float or integer or double. Alright, so let's see how I can check that out. So account number, let it be some string, I say some number like that, and let's say the balance amount is 8,000. Alright, so this should work perfectly fine, showing the balance amount as 8,000. Alright, now this can be of double data type. If I say just 8000.93, should display 8000.93 there. Okay, and this can also be of type float, so this can be of type float. Yes. So you just observed that a template class can have any number of generic type T, U, V, Z like that, or T1, T2, T3, and any data member of the class can be of different types, and accordingly you have to specify in the constructor and also use them while performing the subtraction. Alright, so one important thing is whenever you are withdrawing some money, the balance amount can again be of generic type, float or double. So there you specify exactly same type as you, right? If it is balance is float type, it should amount withdrawn should be of float type, and likewise. Otherwise there will be some loss of data whenever the conversion is not going to happen properly. So here if I say void withdraw, and here U amount, you can check if balance minus amount greater than equal to 1000, then you can say balance minus equal to amount, CF transaction successful, end. Alright, and in the else part you can just throw an error, insufficient transaction paid, insufficient balance. Right. So now here we have created the object B1. We are showing the details. If I say B1 dot withdraw, and it's of type float, so I should pass some 400 M. It should go through correctly, and the balance should be some 7,600 or transaction successful. If you wanted to see the details again, so B1 dot show again, you will see after the withdrawal the balance will be different. Okay. So to summarize, what we learned today is template functions and template classes. So if whenever you want to write a single algorithm for different data types, then you always think of template functions. Similarly, if you have a class which has some data types which are of generic in nature, like the one we saw in the example of a bank account, the account number can be numeric in some banks, it can be of alphanumeric in some banks, so we have to make it generic. Similarly, the balance can be declared as double or float depending on the requirements, and accordingly we can define different type names and use them inside the class to define the data members and carry out the operations as required. So generic classes and generic functions are very useful to reduce the repetitive coding, and also once you write, you can use data of different types to carry out the required operations. But in certain cases, some specialization is required, as we saw in the case of finding max of two strings, where the two string literals cannot be compared just as we compare two integers. We have to do string specialization or the template function specialization, as we demonstrated in the case of max of two string literals, and it worked fine. Alright, thank you for watching. We shall see you in the next lecture.